Number 139, solving a motion problem. This is going, now actually, before we even start this, let's introduce you to a formula that you already know. If you've ever been in a car and perhaps pulled over for speeding, we know that that's calculated by miles per hour or kilometers per hour, depending on which unit you're using, meters per second. Nonetheless, speed equals miles over hours. Speed equals distance over time. Rate equals distance over time. And if you multiply both sides by t, what do you get? Distance equals rate times time. You had this formula memorized before you walked in. It just needed to be pointed out to you. Nonetheless, let's go ahead and take a look at this question here. It's telling us that Matt averaged 45 miles per hour traveling from Chicago to his log cabin home. Returning home by a different route that covered the same number of miles, he averaged 55 miles per hour. What is the distance between the two locations if his total time was 135 hours? Now, it sounds as if there was probably traffic driving out there, and maybe perhaps he left at a better time on the way back because he made better time. He averaged 55 miles per hour. Okay, so what we do is we make a table. We're going to fill in the blanks here, but you go ahead and make a 2 by 3 table here, 2 rows by 3 columns. Rate times time equals distance. All right, we're eventually going to do that. And we label 1 is Chicago to the cabin. Well, what do we know about that? We know the speed is 45. We know the return trip was 55. This is the hard part here, time. You have to label one of them as t. They tell us here that the total travel time is 135. So they were telling us here that if you add these two together, you get 135. So whichever one you call x, the other one's 135 minus x. Or t, 135 minus t. We could have called this one x, and that one would be 135 minus x. Either way, if you were to add them up, you would get 135. We're not going to do that, but if you did, you can see the t's would cancel, so this works out. What is distance? Rate times time. 45 times t. So we put this here, 45t. 55 times 135 minus t. So here's 55 times 135 minus t. All right. Now, what do we know here? Same number of miles. We know that this distance is the same as that distance because it covered the same mileage. So 45t equals 55 times 135 quantity minus t. We go ahead and distribute the 55. There you go. And we add the 55 to both sides. Divide by 90, 82.5. And then then it says what? Find what is the distance between the two locations. Well, this gives us the hours that was traveled to and or from. So we now know that what we need to do here is plug in 82.5 for t, and we should be in good shape. Now, if we plug in 82.5 t here or there, it doesn't really matter where you plug it in. You're going to get the same answer because this covers the same distance. So 45 times 82.5 is 3,712 and a half miles. Next one. Michelle traveled against the wind in a small plane for 3.5 hours. The return trip with the wind took 3 hours. Find the speed of the plane that traveled 220 miles per hour in still air. So, first of all, does it make sense? Against the wind, 3.5 hours. With the wind, 3 hours. Does that make sense, first of all? That's what you want to do. Make sure it makes sense. Then we make another table. You label one of them is going to be against the wind. The other one's with the wind. That's our two circumstances. Just like in the last one, we had to the cabin and from the cabin. So here you have with the wind and against the wind. Now against the wind, what was the speed? Or what was the time? 3.5 hours. With the wind, 3 hours. Now this time the rate, 220 minus W. What is W then? W is going to equal, see, because what do they want us to do? Find the speed of the wind. That's what we want. We want the speed of the wind if the plane travel 220 miles per hour in still air. Okay, there we go. There we go. All right. So everyone's got the question down. We're in good shape. Okay. So now W equals what? The speed of the wind. Okay? So here we go. Same principle. Rate times time equals distance. So 3.5 times this is this. 3 times this is that. There you go. The distances are definitely the same. So we go ahead and set these two equations equal to each other. 3.5 times the quantity equals 3 times that quantity. This should be 220. Thank you very much. 220. All right. Then we multiply, and actually that number is wrong. That should be 660. We're going to be making some corrections on this one. Hey, that's the way the world works. No big deal. And let's see, this side's okay. 3.5 times 220. Let's just double check. 3.5 times 220. 770. Now we're going to subtract. This should be